welcome back. As you know, we've been on vacation, so it's been a little while. We also had some technical issues, and so for a little while we're only going to be releasing videos occasionally. But we've got something a little bit different for you today. Perhaps a little bit controversial. While we were exploring the mountains, we received a new package from our cousin. She'd promised us something crazy, so we were very interested to see what she'd managed to source for us this time. Let's unwrap our present. Here's the foil package. Very mysterious indeed. Let's see what's inside it. Holy crap! Are they what we think they are? The answer is yes. It looks like our cousin has sent us a large bag filled with tranquilizer tablets. To be exact, diazepam, otherwise known as Valium, one of the first benzodiazepine drugs to be invented, and still used in medicine. So let's get these out and first see exactly what we've got here. About 70 tablets in total, most of which are the light blue colored 10 mg ones, and there's also a few white colored 5 mg ones. Well, diazepam isn't that bad. In some countries it's restricted because it can be habit-forming, but it's still a very common medication. And if you look carefully at these tablets, they are actually very old, well past their expiry date. We've got the white ones, and then the pale blue ones, as you can see, are of varying quality. Some are faded and some are chipped, possibly from transit. And this is exactly why we've got them. These are stock which were old, out of date, and hence going to be destroyed. So what better way to destroy them than to do some experiments? All in total we've got around 600 milligrams of diazepam in these tablets. In theory anyway. As a background, diazepam and other benzodiazepines are drugs which have an indirect effect on a neurotransmitter in the brain called gamma-aminobutyric acid, or GABA. This compound regulates the excitability of the neurons in the brain. Too little GABA and the nerves become overexcitable. Too much GABA and the nerves become less excitable. And it's this latter effect that benzodiazepines have. They increase the amount of GABA, and as a consequence have a tranquilizing, calming and sedating effect. There's a catch though. Your body gets used to them very quickly. If you take benzodiazepines for a period of time, they seem to lose their effect. You need to take more in order for them to work. But if you stop suddenly, your brain has got used to the effect, and so the result is too little GABA, leading to paranoia, anxiety, phobia, convulsions, and even death are possible. Okay, it's time for our standard protocol. Now we're in business. Let's transfer the coarsely crushed tablets into a container and weigh our starting material. Around 11.5 grams of powder. So here's our plan. Diazepam is not very soluble in water. At the same time, some of the tablet binders and fillers may be, and some may not be. However, we do know that diazepam is relatively soluble in dichloromethane, hydroxymethylcellulose, stearates, and other fillers are unlikely to be soluble in this solvent. So the theory is that maybe we can get the compound selectively into the DCM. We'll give it a go. Here's a 200 ml flask, so first of all we'll get our crushed tablet mixture into here. Don't breathe in the dust. We don't want to get tranquilized. Okay, now we've measured out 40 ml of cold water. This should be enough to dissolve anything that is going to dissolve. Let's give it a good stir. What is immediately interesting is that the blue color has actually gone into aqueous solution. This could be very useful if it stays there when we add the dichloromethane. So let's do it. Here's just over 40 ml of dichloromethane. This should dissolve out our active pharmaceutical. We've got 2 layers, and some insoluble solids. We'll get a stir bar in. And now we'll stir the mixture for a little while automatically in order to dissolve as much as possible. Not too crazy with the stirring because we don't want to risk forming a horrible emulsion. Okay, 10 minutes later. Well, whatever the coloring is, it's water soluble and not organic soluble. Which is great news because otherwise it could have been difficult. There's still a bit of solid in the mixture, so first thing we're going to do is filter the mixture using a vacuum. To maximize the extraction, we took the solids and washed them well with another 30 ml of dichloromethane. We left the solids and the solvent stirring for another 10 minutes. Then we filtered again. There's some solids remaining and we're going to assume that these are useless, so we'll discard these down the drain. And here's our filtrate. 2 layers of water and dichloromethane solutions. So let's get this into a separating funnel. That bottom layer is looking very clean. Let's drain this off. Looking good. We'll wash the liquid layer with 20 ml of dichloromethane to make sure we've got everything out. A good shake, and then we'll let it settle. Here we go. And here's our combined layers, a clear DCM solution which hopefully has our extraction product in it. The blue aqueous layer is very pretty, but contains nothing of interest, so we'll discard this. We add some anhydrous magnesium sulfate to dry the DCM solution. And we'll decant this carefully into a dry round-bottomed flask, so that we can remove the solvent. Here we go. We'll remove the solvent by heating very gently and allowing the dichloromethane to evaporate off. And a few hours later, being careful not to heat too strongly, we've got a flask full of crystalline solid. There's also a slight yellow coloration in there as well, which must be due to some sort of impurity or coloring from the tablets. Okay, this is pretty dry, so let's scrape it out and see what we've got. Here it is. 0.55 grams of a pale yellow crystalline solid. In theory there were about 600 milligrams of potential product to extract, so if pure diazepam this would be a 92% extraction yield. We're not quite that optimistic. This probably does contain some minor impurities from the tablets as well, but not much. This solid is likely to be mostly diazepam. Given that a few milligrams of this will have a strong physiological effect on you, we're going to have to treat this in the same way as we would a cyanide salt or something equally as toxic. 550 milligrams is one heck of a lot of pure substance. Pretty dangerous in fact. Okay, so what can we do with it? The answer is not a lot, chemically speaking. But one thing we're interested to try is to see if it's detectable using one of the standard drug testing methods. So first of all, we're going to prepare a small amount of a test mixture called Froedhe's reagent. We've got the 100 ml conical flask with a stir bar set up on a hot plate stirrer. And here are our 2 ingredients for preparing Froedhe's reagent. First of all, 40 ml of concentrated 98% sulfuric acid. Let's get this in the flask. And now our next ingredient. This is 0.2 grams of ammonium heptamolidate tetrahydrate. It's a rather unusual and expensive chemical and we were recently lucky to find some. Let's add this. And now we'll stir the mixture and gently heat it for about 20 minutes. The molybdate salt takes a while to react and dissolve, forming a solution of molybdic acid. Here we are 20 minutes later. It's mostly dissolved, and the mixture has a faint brown color, although we think this might be due to dust on our stirred bar rather than the desired color. We let this cool. And now let's test. First of all, there are a couple of classic tests which will first prove our reagent is active. First up, here's a little bit of powdered paracetamol in the bottom of a beaker. And a couple of curious ants. Let's add the reagent. Pretty quickly you can see a pale blue color forming in the mixture. This is classic for paracetamol, so our reagent is looking good. You can see the color better with a white background. Okay, let's do another quality test. This time we'll use the small amount of cane sugar. And soon we've got the yellow color forming. Again, this is the standard reaction, so it's looking good. So let's do it. Here's a small amount of our extracted diazepam product. Interesting. There's no color change, even after sitting there for a few minutes. In fact, Froedhe's reagent is normally used for an indicative test for opioids and opiates, so this isn't too surprising. But it was worth the try as it's not well documented. As for the rest of our product, there's not much we can do with it chemically, and short-term memory is kind of fun to keep. So we'll find a thorough way to dispose of it. We'll see you again when we have full video editing back up and running, probably in a few weeks. Stay tuned.